Alrighty, the final thing to talk about here in section 9.3 has to do with paired data and doing a one sample t procedure or a one sample t test. Now, we've talked about this example before. We talked about it when we did confidence intervals back in section 8.3. Quick reminder, and again, this is from your book. I'm talking through that example, but hopefully to clarify a few things that Darren did here, and I'm going to show you again on your calculator. But back in 8.3, he introduced this idea. Said there are 11 volunteers. These are people who apparently already we know are caffeine dependent. And so what they did is they took away their caffeine for a while, and then what they did is they half of them on one day they gave them actual caffeine, and half of them they gave a placebo, and then switched it around. The half that had gotten caffeine got a placebo. The half that had gotten placebo got caffeine. So the order was random between the two. The order that they got the treatment. And then what they did is they measured somehow their depression level. I don't know how, but they quantified that. And so, for example, subject number 1 had a depression level of 5 with caffeine and a depression level of 16 with the placebo. Number 7, depression level of 0 with caffeine, depression level. I don't know how they measured depression level. It's some way of measuring that the researchers knew about. And okay, so but the thing is, the first question says, why did they reverse the order? And that's interesting. It does matter, but we're not going to talk about that right now. We're going to talk about B. Carry out a test to investigate the researcher's question. The researcher's question is, does caffeine or lack of caffeine increase people's depression level? Now, here's the problem. We don't know what each person's original depression level. There are some people that are just more or less depressed than others. And so it might be that so we can't really compare from one person to the next. So we have to compare each person with themselves, their depression level with caffeine and their depression level without. I don't really care about either of these numbers because these numbers are relative to that person. What I do care about is what's the difference. And so our hypothesis test is going to be about the difference between these two, not either of the values. And so, state, plan, do, conclude, here we go. If caffeine deprivation causes no effect on depression, here's what we would expect, that the difference, the average difference would be 0. If I take placebo minus caffeine, one time this would be higher and this would be lower. That would be a positive difference. But then one time this would be lower and this would be higher. And so the average difference would be 0. Sometimes the placebo group is higher, sometimes the caffeine group is higher. And if there was no difference in caffeine versus the placebo in terms of depression, we would anticipate that that difference would be 0. That's what this null hypothesis is saying. It's saying sometimes the null hypothesis is called the hypothesis of no difference. In other words, our hypothesis is that the average difference, the mean difference between these two lists will be 0. But I am suspicious, and so I have my alternate hypothesis that the mean difference really is greater than 0. And again, we have to tell our reader, what does that mean? The mean difference, and we took the placebo minus the caffeine. The order does make a difference. We have to tell, because are we saying the placebo group has higher depression or the caffeine group has higher depression? Which group did we subtract from the other? If I took caffeine minus depression, that would end up being a negative number, which would suggest that group is less depressed. If I take depression group the placebo group minus the caffeine group, and that turns out to be a positive number, that would suggest, if that's positive, this group is more depressed. So positive, negative does matter here. We have to just be careful about which direction we're doing. So we tell our reader, oh, we took placebo minus caffeine, and we're wondering if that difference on average is positive, if there is some greater depression among those with the placebo than the caffeine. Since they didn't tell us a significance level, we're going to use alpha equals 0.05. State, plan, do, conclude. You know, the plan part of it has checking your conditions: randomness, normality, and independence. Random. What was random is the order. Half the group got the placebo first, then the caffeine a couple days later, and half the group got the caffeine first, then the placebo. Normality. Now, we don't know this. We don't know, and there's only 11. We don't know about the population. There's only 11, so the central limit theorem doesn't kick in. So we look at the difference. Darren made a couple different plots here. Our real question is, are there any outliers, or is there any crazy skewness? And among those 11 differences, there really isn't, so we're going to move along. Independence, we aren't sampling, it's each person against themselves, so the 10% rule doesn't even make sense here because it's these 11 people, but we are saying that the treatments are independent of each other. The depression scores are for each person are independent from the others. So that check for independence is a little bit weird here, but we still go ahead with it. Darren he doesn't even show the calculations here in the do portion of it. Now let's pause and go to your calculator. You can see what he did here, but let's go to your calculator. Actually, before we do that, I want to use this picture right here just to talk about what is our calculator going to tell us. The null hypothesis was that there was no difference. And so we build a whole world of sampling distributions in which the mean difference really is 0. Sometimes I would expect to get a little positive difference. Sometimes I would expect to get a little negative difference. I would expect to be somewhere around here, but if the null hypothesis is true, that the mean difference is 0, I would expect the mean of my sampling distribution to be 0. So let's go put this in a calculator, have our calculator do it with our sample of these 11 people and see where it fits in something that looks like this. Now go to your calculator. Okay, at our calculator we still have the test up from the previous video. I don't care about any of that stuff. Again, we're going to go to Stat. We're going to scoot over to Tests. This is a t-test because it's a test for means in which the only standard deviation we will know is from the sample data, which means we will have to use a t-distribution instead of a z, or standard normal distribution. So it will be a t-test. Again, I have not encountered a case in which you would do a z-test. You will be doing t-tests. When we click on this, if we're expecting our input to come from statistics, it's where somebody has already told us what the mean and the standard deviation from our sample would be. We could do that, and this is what Darren showed in the book. If you do your one variable stats, you could do that. But if we look here, hey, the data is in my calculator somewhere. I think we better go check that. Stat, edit. A few days ago, I entered list 1. This was the depression level for people with caffeine. This was the depression level for people with the placebo. Now, I'm going to remind you, just in case that wasn't there, what I want to work with the difference between them. I want list 2 minus list 1. So I put my cursor up on here on list 3. I do not put it right here in this spot. I put it up in list 3. And I say, I want list 3. I want everything in list 3 to be list 2 minus list 1. And it says list 3 is about to get populated with the difference between whatever the value is from list 2 minus whatever the value is from list 1. And presto, here it is. This is our difference list. This is what we're actually doing the test on. So, stat, tests, t-tests, data, I know it. The mean from my null hypothesis is 0. I'm building a whole distribution around the idea that there is no difference. But my stuff is in list 3. Now, how did we have our hypotheses set up? Our alternate hypothesis is that maybe the mean is something bigger than this value, something bigger than the mean from the null hypothesis. And so I go out here, I draw it, and it says, oh, that's weird. I can't see any shading. Look at this test statistic. The test statistic is 3.53. It is more than 1, 2, 3. It is more than 3.5 standard deviations above the mean. There is a part shaded here, you just can't see it. The 3.5 says we were 3.5 standard deviations above the mean. That's very unlikely. That has a p-value of 0.0027. That's about 1/4 of 1%. Our p-value is 0.0027. Our test statistic is 3.53. Now go back to the example. Darren's picture looks just like ours. The test statistic was 3.5304. The p-value 0.0027. That's tiny. If the p is low, what do we do? That p-value was low, so I would reject the null hypothesis. I have evidence in support of the alternate. I have evidence that the true mean difference is something bigger than 0. That's what this says. With a p-value of 0.0027, which is below our chosen level of alpha level of 0.05, we have convincing evidence to reject the null. We can conclude that there's increased depression. This is what the alternate hypothesis says. The only difference between this and what we had done before is that instead of using the list of data given, what we are really interested in is the difference between them. How much change was there from one to the other? So that's a paired t-test as opposed to just a t-test. The logic is exactly the same. So that is pretty much everything from 9.